today we're just going to be covering kind of a really high overview of what Web3 is, of what actually is Ethereum, kind of like the core parts of it. But just to kind of get you guys an understanding of like what Texas blockchain engineering is, we're a relatively young, new org, started last year, and we were originally we were called Texas DeepNet, and we were focused on machine learning because this school is a really good machine learning school. But obviously, so moving on to this year, we decided that like blockchain, got really interested in it over the summer. But first semester we're actually Texas DeepNet this first semester, and we're doing machine learning. Kind of realized it's a bit difficult. It's a bit difficult to try to teach because that's one of our core pillars. We want to focus on education, kind of why you guys are here. And obviously, blockchain is more interesting. It was a good decision because last semester we had about 10 people come to our meetings, and now look how many beautiful faces we have here. So that's kind of like the little background of who we are and everything like that. But that's where we are now, Texas Blockchain Engineering. And kind of like the core structure of what the org is we're focused on like 3 pillars, and that's education. So that has to do with our, what I call Blockchain 101 kind of like curriculum. And this is divided into Bitcoin and ETH. So if we had started in the fall, we would have went over Bitcoin 101. And this is where we would have actually went and talked more about like what is money, and you start kind of having like more of those philosophical economic conversations. But obviously we're skipping that. We're into developing. We're actually wanting to build dApps. So spring semester is going to be ETH 101. That's where we are now. And there's going to be more protocols we'll probably do, maybe like Solana, Near. Our hackathon is coming up in March. But then that leads to the next part, projects and hackathons. So we really want to, like the reason why we are having this education session, the reason why I did come and work with Texas Blockchain is because there's a lot of protocols. They're reaching out to us. They want people to be able to build, and we need kind of like a group that wasn't there before. So we're kind of providing this education section, this structure to get more people involved in the hackathons. But once you kind of get out of Blockchain 101, you're going to be kind of encouraged to propose your own projects. We want you guys to be creative. We want you guys to work on stuff because, like the hackathons, we have Near coming up. They're willing to give teams up to 50, 100K grants for the projects. So this is a really important stage where you're really learning, but also trying to be creative. So as you're learning, think about things like, how can I apply this? What are some things I could build? And so that's our second core pillar. And then the last and not least is kind of incubator. So our advising professor, because we're working towards being sponsored under the computer science department. He has an incubator called, I think, what is it, Eddie? Do you remember?
Block Boost.
Huh?
Yeah. Block Boost.
Something like it. It's something, but our advising professor has an incubator himself, kind of, and we're going to get
It was Block Hub.
Chain Hub. Yeah, our advising professor has an incubator called Chain Hub, and so with this is kind of like, you kind of see the transition. So you learn, then you start to build projects. If your project's really interesting, then you get to join the incubator, and that's when we'll actually have like where you have to apply. But that's really the full core structure and logistics. Our meetings are on Tuesdays. This is the main meeting. And then we also have meetings on Fridays. It's kind of extra. It's going to be led by Bennett. He's actually all the way up there. Say hi, Bennett. But so there's going to be that's going to be more about just going over reading smart contracts, getting kind of like a feel for what's actually out there, what projects are already kind of been deployed. And yeah, you don't have to go to those sessions. Those are mandatory, but these ones are, and in person, obviously, this is a location. Just to clarify, so Texas Blockchain and Texas Blockchain Engineering are separate orgs. Texas Blockchain, you can informally call them Texas Blockchain Finance. They are the Macomb sponsored. We are, like I said, working towards being sponsored in the computer science department, but we're all under the same vision, same mindset. We want to make UT a really big player in this space, and that's all for who we are. But who am I? You're probably like, why is this kid talking? Who is this dude talking up here? So I'm Armel Tala. I'm the president of Texas Blockchain Engineering. What am I? I'm a sophomore, and I'm a double major in computer science and math. And so last summer, intern at Google, returning there this summer. But more importantly, just kind of like my background in blockchain. Really, I bought Bitcoin in 2021. I don't have that really cool story being like, hey, in 2016, or some people lie to you, 2008, I bought Bitcoin. I did not do that. I think I was like 10 or something. So I bought 2021, but then you just kind of fall into that rabbit hole. If you haven't already, it's a really deep rabbit hole. I don't know when it's going to end. I'm still wondering. And from that point on, just kind of really became obsessed. I would say I'm an economist at heart. I really got interested in Bitcoin from an economics perspective. And then obviously as a computer science major, the technology was really interesting. And now I'm more interested in kind of like protocol development, I am kind of leading you guys through a dApp building session. But this would not all be possible without my great team. You have Roshan, Taki, Furkan, Camille, Akash, Macy, and Koi. So these are people, kind of see some of them are in the front. We have a few not here today, but they're gonna be the ones that are gonna help you. We want this session to be open to everybody, meaning that you don't need to have programming experience. So for whenever you do get stuck, all of these dudes are computer science and our amazing Macy, she's not here, but all of them are computer science and ECE, so they know how to program. They'll be able to help you out if you have any questions. And there's a bunch of people out there that are also doing it as well. But let's actually get to why you're here. What is Web3? First, just kind of give you guys a timeline. So Web 1, 1990, 2005. This is where you can think about, everyone knows the dot-com bubble, the dot-com crash. This is the beginning of the web. The web originally started really as a place to share information and access and kind of like organize it. And it was started by like a research lab. And there, it was, what is his name? I think it's like Sir Tim something Lee. Really interesting dude. But so it started really as just like a place for you to find information. Then Web 2, this is kind of where you see apps like Twitter, YouTube, and Facebook really start to come up. And then Web 3 is kind of where we are now. And as you see, Web 2 is still going on. Obviously, we're still using those platforms. Web 3 is kind of really what we're here for. And so some people will say like, hey, I thought it started in 2009 with Bitcoin or 2015 with Ethereum. Really, it started getting popular. The word Web 3 really didn't start kind of, I guess, becoming mainstream to like really 2020 when you had that big run up towards the end of 2020 and the beginning of 2021. But the main characteristics, at least in my opinion, that kind of define Web 3 is decentralization, ownership, and accessibility. So decentralization meaning no one controls it. Ownership meaning that anyone that isn't actually the ones that built it, can actually own a piece of a network. And then that network, the ability to own a piece of that network is accessible to everybody. So it doesn't matter what country you're in, what you look like. You don't need any type of credentials. You just need to have internet access and you'll be able to open. But we'll go more into detail. So Web 1, Web 2, Web 3. So Web 1 can be defined as the information economy, and with the information economy, that really means that people were just using it to read. You did have the ability to write. I'll show you guys an example on this following slide, but it was really focused. People kind of forget that the web first actually started as a decentralized protocol itself. So this whole notion of like decentralized web, like this isn't new. Like that's what the original web was. No one owned it. It was community driven. It was a bunch of people that wanted to build something that was going to be helpful for them, right? And again, being really the main thing is you should think about is Web 1 was reading only. People it was those ugly web pages that no one really actually like used besides to find information. Now Web 2, you can think more of this as what we have today as platforms. So really, it's really big on platforms. So what these platforms did is they just extended the functionalities of Web 1, of what the internet had to offer at first. Because could you imagine trying to look at things on Google without, could you imagine trying to look at things on the web without actually having Google? Like that would make things a lot harder. You kind of have to know how to navigate the URL. You have to be a little bit technical. So what they did was make it a lot more user friendly. But with that being said, they're under a company, Centralized and everything like that. And so they ended up collecting a bunch of our data, and kind of a lot of the issues that we have now with what you're talking about. What is it specifically? We have the fake, false information, fake news, all those different type of issues that you see in the current web. But so this can be seen as read and write, as now people were able to just go on these platforms. You can scroll through Twitter, read someone's really funny tweet, look at someone's cool TikTok or YouTube video, but you can also now start to produce content. So it's kind of like, there's two sides to it. It fully became an actual, what they call, platform. And now Web 3, you can view it as the token economy. And this is, Web 3 kind of combines Web 1 and Web 2 as in that open protocol, open source, decentralized type of nature, but also giving you actually the full functionalities where now we're not going backwards, but we're still having the same abilities to try to search this new web, have the same type of tools, same functionalities and everything, but this time with an incentive mechanism with tokens and everything. And I'll go more into all of that. But yeah, so this can be defined as read, write, and execute. And really what execute, so for those that aren't computer science or in electrical program before, so read, meaning you have the ability to read it, write, you have the ability to write to it. But execute, that means you have permission. So from the actual terminal standpoint, if you're messing with if you're trying to enter if you're using a terminal and you're trying to enter what is it, like a file or something, right, or a folder, then you having execute means you can actually access that folder. You can actually execute the files in there. But in the terminology for crypto, the way you can think about this is everyone has access to like Ethereum's network. You can see any smart contract that's on there. You can run any smart contract. You can call it yourself in your own code. Like it introduces this thing called interoperability and composability, where all these different contracts, you don't have to rebuild things from scratch again. You can use ones that were built before. So, but these are kind of the examples. Wikipedia is actually an amazing analogy for what like really Web 1 is. It was actually built during that time, but a lot of people like now we use Wikipedia just to read. I don't know any of y'all that actually have contributed towards it, which that'd be really cool if you did. But a lot of us we use it just to read information on there, and that's kind of like the whole emphasis of what Web 1 was. Now Web 2, like I mentioned, this is Facebook. All these platforms that came to be, where now they're not only attracting users, but they're also attracting business. That's kind of like their business model, where they're not selling. They're selling your eyeballs, right? They're fighting for your attention, and so they're taking your data to be able to specifically target you in ads and everything. But you don't know anything of how those algorithms work. You don't know, like when people talk about what the TikTok algorithm, the YouTube algorithm, when they're posting content. You don't know how that thing works. You don't know what type of data they're collecting until now, when we put more and more pressure for them to really start to be more transparent. Now Web 3 is really defined a lot by kind of DeFi protocols. That was the biggest thing. That it's just kind of natural. You have these tokens. You have kind of like this built-in way of payment, right? That Bitcoin kind of led and Ethereum introduced, and it really started. That's where you really started seeing DeFi protocols come up. There's a lot more to be seen on what can actually be built. But really, like biggest thing to pull away from this is that anyone can access these protocols. Like anyone can buy Bitcoin. You don't need a bank account. If this was first semester, we would have gone more into that, but I will leave that for next semester. Now, so why does decentralization matters? Why does decentralization matters, right? And so these platforms, these centralized platforms, they have a pretty predictable life cycle. So they start off when they first begin, they're really focused on attracting. That's kind of where you see like this. They follow an S curve, right? And everyone's heard of like the network effect. Does anyone know what the network effect is? Anyone define it? Anyone? Yeah.
It's like when like a product's value increases as the amount of users increase.
Exactly. And so in the beginning with these platforms, they're a multi-sided network, right? And so they're trying to bring in not only users, but they're also trying to bring in developers, at least at the beginning. And so at the beginning, they were pretty open. Like people could come in, make content. Developers actually had like you could kind of build like third-party extensions. I think they refer to like Twitter in this sense. But so at the beginning of these platforms, they're trying to attract as many users as possible, right? And they're really nice at that sense. But once they kind of reach the top of that S curve, they begin to extract now. So growth becomes harder because it's like at a point you're gonna reach where everyone's kind of joined the network already. Like you can't really grow in terms of numbers. And so how do they pull us? How do they start to extract value? How do they continue to grow that company? And that's what with your data, right? They start to collect your data and they use that to create specifically targeted ads, and they sell that to advertisers and everything. So the negatives with centralization is obviously you're giving up your control, you're giving up your data, and you also become more vulnerable. And when the relationship with these platforms, and when in this chart it talks about the relationship with complements, and that those complements are developers, creators, businesses that get on those networks. So it's at the beginning they're cooperative, right? They're like, hey, y'all are cool. You can use these APIs we have, everything like that. You guys can build stuff and reach it, extend it. But then over time they start to compete with those because they're like, hey, we don't have we're trying to now figure out how do we extract as much value from this finite amount of network participants we have, because like I mentioned before, they've reached the top of this S curve. They can't really grow anymore through natural ways. So now enters Cryptonetworks, right? So like I mentioned before, the early internet itself was a protocol. It was decentralized. Like this whole idea of people really getting excited, like decentralized web. It's like we've had that. We just never we kind of didn't see it through. We let decentralized platforms come on and extend the functionality. But the early internet was a protocol, and it was by nonprofit organizations or just individuals themselves contributing. It was open source. And it relied a lot on the interest of kind of like the whole community in order to get adoption. So those early people on the internet, they were really big. They really wanted people to use it, but they didn't kind of like understand how to get a lot of people on there. So it really took a lot of work for all of them. That it took a community effort to kind of drive adoption, right? But so with crypto networks, that's a lot different. You have different incentive mechanisms. And the thing with crypto networks is that they use consensus mechanisms to maintain and update the state. I'll go more into what that actually means later. So you guys have probably heard of consensus like proof of work, proof of stake, right? And so that's like the difference. They use it to govern, and I'll explain more about why they're using these networks. And also, but cryptocurrencies are an incentive, right? So like I mentioned, the early internet protocols, they kind of had to, it was kind of like a wishful game. Like, I really hope people start to adopt this thing called the internet. I really hope people start to use the web. They're maybe writing blogs and trying to just produce free content about that. But now with crypto networks is you have these built-in incentive mechanisms like Bitcoin. So a lot of people, when you talk about like crypto, they specifically are thinking of the currency, the cryptocurrency. But it is a network first. But the currency is the incentive for people to participate in that network. And now crypto networks have a way to actually grow neutrally. And so one of the ways is that it's a contract. Like whenever you're using the internet, it's kind of a bit of this where we have like social contracts. You have a social contract with the government, and you're really having a social contract with that network that you're using, whether that's Twitter, Facebook. Sometimes you sign it explicitly whenever you do get the terms and agreements. But crypto networks have like a natural contract that you're kind of signing, and it's enforced by source code. It's enforced by the code that's written. Like everything is not governed by a person. If it's written in code, it's put on the blockchain. It cannot be changed, and you can go back and see that. And there's ways for people to actually voice their opinion. So this is the second part: is these platforms can be kept in check in what they call like a voice and exit. And so the voice is really governance tokens. So if you've heard of these before, this is where if you own, let's say, I'm trying to think of an actual governance token. Let's just say you own ETH, right? And you own ETH in a certain network, and because you own ETH, you're allowed to have voting rights in that network. So whenever there's changes that need to be made, you can actually have a say in it. So that's one way. You're voicing through governance tokens. And also, there's offline things like Discord. So Discord's really big in the community of crypto, and that's where people just kind of talk and actually be able to communicate and like maybe actually say words and not just vote. And then also exit. So the form of exiting can be seen as where you sell your token, right? So the difference is with like companies now is like with shares and everything, you generally can tell like if a company's doing good or bad based on the share price. This is not a finance class, so I won't go in that. Like, it's not a perfect representation of how well the company is doing, but essentially this is the same thing with the network, where if you don't like the way a network is going, you say, okay, I don't want to participate in this anymore, and people can voice their opinions by selling their tokens, and therefore the price goes down, and those people that are actually the developers working on it, they get a feedback saying like, oh, people don't like the changes we're making, and everything like that. So there is this neutral way, sorry, I keep saying natural, this neutral way for these crypto networks to actually grow compared to centralized platforms like Twitter, Facebook, where you don't have a say in it. You just kind of have to take whatever changes that they want. But there's big limitations in actually these networks fully reaching the top of their S-curve, and that's performance and scalability. We'll go deeper into all of this, but if you heard like proof of work being unscalable because of how much energy it consumes, and so that's why Ethereum itself is switching to proof of stake. And I'm using all these terms right now, but I promise I'll get into it. But one just really interesting thing to think about is we're still super early. We're still super early in these in crypto right now. And like I mentioned before, a lot of the kind of applications that you see on these networks are DeFi protocols, and to me that's boring. I'm not gonna lie. I'm a finance. I love econ. I love finance. I love everything. I'm big in investing, but that's not what interests me when it comes to crypto. It's like, can we actually start to build things like a decentralized Twitter, decentralized YouTube? Like, what's the point of having these decentralized systems if the only thing we're getting is finance, which is really huge because you're uplifting $1 trillion industry. But so with this quote, software is simply the encoding of human thought, and as such has an almost unbounded design space. So right now we just see DeFi protocols, but I do not don't keep your imaginations limited to just those protocols. There's a lot more things that can be built, and as we work through the kind of like the limitations of performance and scalabilities, as those get worked out, you'll start to see a lot of really interesting projects start being formed. So that's just something I wanted to put out there. Okay, now to the main part. So that was kind of like the Web 3.0 aspect of it, but to the main point is we're talking about Ethereum, right? And so there's no reason you guys should trust anything I'm saying. I could know nothing. Like, I'll be honest with you, I know a good amount. I've done like a lot of research. Obviously, that's why I'm up here and trying to talk, but I'm not gonna know everything. And I pulled the main source of all the information you're gonna get is from this book, Mastering Ethereum. This is a book that's recommended on the ethereum.org website when it comes to like things you wanna read if you wanna learn more. And so, I don't know his last name, Andreas Antonin. I don't know his last name. I'm sorry, Andreas, if you ever see this, he probably won't. But then there's also Dr. Gavin Wood. He was one of the co-founders of Ethereum. So the book is pretty credible read. Pretty easy read, so you can go ahead and actually read this yourself if you want. If you want it, just let me know. I'm not gonna say how I got it. But then also additional resources. If you know Andreessen Horowitz, amazing venture firm. So kind of pulled some of the things from crypto startup school, MIT cryptocurrency engineering, and then there's also just UT, because our advising professor also teaches the course. So that's a lot where the information is coming from, because I don't want you guys to just trust me. You should know like where the information is actually coming from. But now, so when we're talking about Ethereum, a lot of times people are going to bring up Bitcoin because Bitcoin was the first. When we talk about blockchain was never actually a word that was termed when Bitcoin first came out. It was just Bitcoin. Everyone then kind of defined it as like, okay, there's Bitcoin, but it doesn't do a lot. It's a specific application. It's a specific application of a blockchain. So people extracted this word blockchain because that's fundamentally the technology behind it. But similarities, they're both a peer-to-peer network. And so meaning that I send you Bitcoin directly through payments, I send you Ether and everything like that. There's no middleman in between. That is the beauty of crypto, of Web3 and everything like that, is that things are governed by code. It's governed by these computers that are running code, rules, consensus, and everything that has been already established way before. Then there's the Byzantine fault tolerance consensus algorithms. And so the Byzantine generals problem, this is a really, really important problem that needed to be solved when we're talking about crypto. And so what the Byzantine problem is that, so you have these generals. Let's say you have 4 generals, and these 4 generals have each their own armies, and they need to communicate with each other. They need to communicate with each other about how they plan to attack. And so there's like, let's say there's 2 options. Either they can attack or they retreat. The thing is, they all need to reach a consensus, and they all need a way to safely get their message. They can only communicate with each other through messages, and they need a way to safely know that the message they receive from someone else is valid, they're trustworthy, and also how do you actually send those messages across without having someone steal it or whatever, right? And so that's generally the problem. And so to apply this to crypto is, how do you get these different nodes? Because what crypto is a decentralized network. So how do you get these different nodes in the network to all agree on the same kind of state, like the state of what the network is actually doing, like who owns this amount of Bitcoin and everything like that. So how do you get these computers to agree on that? And that's what like proof of work, proof of stake is. I'm giving you guys a really high level overview. Again, we'll go deeper into all of this, but this is just the beginning. So just kind of get you guys thinking about it, and then also using cryptographic primitives. So this is like using SHA-256 to hash blocks, using cryptocurrencies themselves, and everything like that. Now, so the differences. So Ethereum is a utility currency. So when you're thinking about Bitcoin and Ethereum, Bitcoin is itself, like I said, is application specific. So it's just trying to be money. So it's more of an alternative to fiat currency. But Ethereum is trying to power what they call a world computer. So it's a general purpose computer, and they use it for what they call gas fees and everything. So it's actually used for a certain purpose in the network, right? And then, like I said, Bitcoin is application specific. Ethereum is general purpose, and then Bitcoin has a very limited kind of programming. Not actually, it doesn't have a programming language, a scripting language. So the only things you can kind of evaluate is true or false with transactions, and that's again for a specific purpose. It's only wanting to be money. But Ethereum is actually what they call Turing complete, and I'll talk about that more. But yeah, so this is just kind of a bit of a graph to get you guys kind of see a little bit of the differences. So you guys know Bitcoin, Satoshi Nakamoto, the kind of like it's almost like a story out of a comic book or something. And then Ethereum, Vitalik Buterin, Charles, and then Gavin Wood. There's a lot more founders with Ethereum, but you guys see the dates. I won't go that much more into it because I've already kind of touched upon everything. But last part until we get into an activity, because we do have an activity, so it's not going to be me talking up here for an hour. We'll spend 20 minutes on this upcoming activity, and it's going to be about this. So the components of a blockchain. So a blockchain generally has these 8 different components, and so first off is a peer-to-peer network. And so it's essentially what allows us to send money directly to each other and not needing a middleman, and all that's done through, like I said, the consensus algorithms, everything. And then so when you have this network, you need kind of messages to be sent through this network. Like, what's the point of having a network if nothing's actually going through the network? And what they say messages, but these are essentially just transactions. If you're talking about Bitcoin, and if you're talking about Ethereum, there's a lot more. Like, you actually have code, and you have like smart contracts going through the network, right? And then with that is consensus rules. So don't get this confused with like proof of work, proof of stake, but the consensus rules are actually what determine like what is a valid transaction, what is a valid state for the blockchain to have. And then with that, you need a state machine. So a state machine is not a hard concept to get your mind around, but it's just it's very abstract, because essentially a state machine is like a mathematical type of, it's like a mathematical kind of like proof or just formula, really just explaining like, hey, there's this current state, like in this state machine, Bitcoin specifically, you have Alice, she has 100 Bitcoin, Bob 100 Bitcoin, and that's like the current state of it, right? But when you're talking about computers, you can extract this like what's currently in memory right now, what's currently like the variable I'm running and things like that. So you need the state machine, but the state machine is used to actually process these transactions and keep state of what, like, if a transaction happens, Alice sends money to Bob, then we know that the state has changed. And after that, once you've taken, you have the state machine, but these different states, they need to be saved, right? You need a record of all this happening, or else you don't know if someone would have messed with the network before. And so they use consensus algorithms to kind of create these blocks. But these blocks, generally, what you can think of the blocks in the blockchain, they're just a record of all the different transactions that have happened. And those transactions, like I mentioned, if it's Bitcoin, you're talking about money transfers. If you're talking about Ethereum, there's money transfers, like either smart contracts that have been run. There's a lot more to Ethereum than just the transactions themselves. And then finally, with this block, like how do you decide what blocks are created? How do you decide who's allowed to actually create a block? And that's where consensus algorithms come in. And these consensus algorithms are things like you've heard of proof of work, proof of stake. They're all just a way of saying, like, who gets to create the block? How am I going to trust the fact that you actually did the proper amount of work, or you actually are a valid participant in the network? And that's what these consensus algorithms are, and they enforce the consensus rules. Last, you need an incentive mechanism, because why would anybody want to create a block? Why would anybody want to participate in the network? Why would anybody be wanting to actually create a block? And if you're talking about proof of work, why would they spend a bunch of money on proof of stake? Why would they buy a bunch of these coins and then stake their coins, right? So you need an incentive to it. And so that incentive is when people do create blocks, they actually get money off of the fees and also what they call block rewards. And last is clients. And clients is just it's just an implementation of like the actual, I guess, source code. So let's say the original source code for Bitcoin is called Bitcoin Core, and then there's a bunch of different, and then it's not actually a bunch of different ones, it's Ethereum. But there's different kind of clients, and these are just different implementations where you download the software and then you run it. And so yeah, those are all the components of a blockchain. But it's not just me, again, I said it's not just me talking the whole time. We do have an activity for you. All right, so now Ethereum has 4 development stages. They kind of outline this in their document. If you go on ethereum.org, you can find this somewhere. It took me a while to find it a bit. But so they divided into 4. The first is Frontier. The Frontier was kind of like the beginning of you just kind of like testing it out, just deployed it out there. And it was pretty minimal. It was Ethereum that's most minimal. So you could pretty do like very basic things like sending ETH to someone. People like they were finally getting people to, I guess, run kind of join the network and do proof of work. But it only lasted like, what is it? It's like a year, not even. So because it was really a test. And at that stage they marked it as unsafe because again they were testing it. And then you move on to Homestead. So Homestead was the second phase, and this is just more. It became what they call safe. It's been tested. And they're like, okay, now we can really start to get people to really start using the network. And right now we're currently on Metropolis, and Metropolis is I can't remember exactly. I'm trying to think. A lot of these stage names are just names for whatever stage. But yeah. So currently we are we're in Metropolis right now. Check actually. I am so sorry. Okay, yeah. I see. Okay, so yeah, currently we're Metropolis, and Metropolis is really just them transitioning into their full functionality of everything that Ethereum has to offer, and you kind of start seeing more a bit what they say is like a bit more advanced dApps on there. So maybe not just DeFi, but currently we're in this stage, and there's two kind of forks on it. There's the Byzantine and Constantinople. And then last is Serenity, and Serenity is the final kind of like the final stage where they want to officially move to proof of stake, because proof of work is unscalable. We'll talk more about that whenever we get to consensus, but Serenity has not happened yet, but this is whenever proof of stake, transition to proof of stake will finalize. Now, like I mentioned before, Ethereum is a general purpose blockchain, and it is a distributed state machine. So some of y'all actually said that, so y'all are actually on the money with a lot of the other networks are distributed state machines, and so it tracks state transitions, and simply like when we're talking about the crypto network, we're really just talking about when people are sending money to each other, and so this can either be stored in like data, with values, and these are stored in key value pairs or key value tuples. And so what a key value tuple is you have simply where the key is like the identifier and the value is the actual, I guess, content of it. So if you've taken computer science, you kind of know what this is. This is more like when you think of maps, and where it's like, hey, I want to identify, like, let's say with a book. So there's different parts of a book. There's like the book title, that could be a key. The table of contents, that can be a key, and then the value would be the actual book name or the book, all the different chapters that are in the table of contents, right? And so that's what it really means when it's saying it's a distributed state machine. It's just something that's keeping track of the state changing, and what's being stored is really either data, and when I say data, I'm really referring to smart contracts that are code, and also the transactions if you are actually going to move money around. So if someone buys an NFT, the state transition will be, hey, this person sent this NFT, this specific non-fungible token to someone else. That represents a state transition. And this, I wanted to give you guys like an idea. Like, and I've used this example a lot, but you see here, like state 1, Alice has 100, Bob has 100, Cat has 1,000. Cat's really rich, and so it's kind of like the transition here is Cat decides, let me send Alice some money. Let me send Alice whatever cryptocurrency we're using in this example. That's state 2, right? So that's really what they mean by state machine. But obviously, it's a lot more complicated when you're actually talking about like the networks and the fact that Ethereum is really just think of it like Ethereum is just one computer. Like your computer has states, right? And every time you kind of do like some type of interaction with it, you click on a web page or you click on some app, you're transitioning into a different state. But this time, you're taking that computer, you're distributing a bunch of different computers that all are storing the same thing, and they all have to make sure they're in the same state. Now, the components of Ethereum, and some of y'all did a really good job, some of y'all did even an amazing job. But so with the peer-to-peer network, the main network is Ethereum main network, and there's also different ones like test networks where you can like run, you can test out smart contracts and deploy them there. And then so the consensus rules. So what makes a state transition, or that's meaning executing a smart contract, that meaning sending a token. That's all outlined in the yellow paper. Now the transactions. So if it was Bitcoin, it would simply just be like a sender, receiver. Bitcoin's a lot different though, where we won't get into that, but the transactions, they include a sender, recipient, value, and data payload. This is if you're trying to execute a smart contract. And now state machine, Ethereum has called what it calls the Ethereum virtual machine. So this is kind of like that. It's an abstraction. So if you understand abstraction, it is like you're taking something complex, you've kind of hidden it over. Like Google, they've abstracted how you actually go search the web, right? Because all you see is the front page. You can just type in something, and you'll find that web page. But so the Ethereum virtual machine is this abstraction of how, like, taking all those computers and saying like this virtual machine is representing the state all these computers are. It represents the state that all these computers are currently at. And now we have a data. So the data structure. So all the state transitions and everything are actually stored in every single computer in the network, and it's stored in a mercantile, what they call mercantile partition tree. If you are in computer science, you can think of this like kind of like binary tree, but it's a little bit different. and then consensus algorithm. So currently, Ethereum is using what they call Nakamoto consensus, and that's what you guys refer to. You guys actually mentioned it, the longest chain, but then they're moving to proof of stake and they're calling it Casper. They call it economic security. So they're using Ethash, which is just like a version, which is just a name they have for proof of work. And then when I mentioned clients, I think I must have not explained it well enough. When I say about clients, it's not like the users or people using it, it's the implementation of that software. So you can have a software written in a specific language like Python, but then they can rewrite the same exact software, same logic and everything. They have to follow, they use a white paper as kind of like that mathematical foundation to what that software should actually do. And so that's what I meant by clients. It's like different implementation of that yellow paper, of the white paper. And so Ethereum has like Go ETH, they call it Guide Parity. So whenever you're talking about Ethereum, you're going to hear people use the word Ethereum is Turing complete. Ethereum is Turing complete. It's not that great of an accomplishment to actually be Turing complete. It's pretty simple. A calculator is Turing complete. So so I wouldn't say like this is like the greatest feat, but it actually is impressive for a few reasons. We'll talk about it. But quick background. So what the name Turing complete comes from one of the what they call the father of computer science, Alan Turing, and he created like this mathematical model of a computer consisting of a state machine. He's like the first one to really introduce the idea of state machines, and simply it's just manipulated by reading and writing to like memory. And so when he created this, he was trying to prove specific problems, and prove them wrong specifically, and he proved that a certain class of problems cannot be solved, and this is called, and the most important one that we'll talk about is the halting problem. And the halting problem is simply like, given a program, given some random input or whatever, can you predict when this program will end? And the answer to that is no, you can't actually predict when the program will end. But so to be a Turing complete machine, or what they call a universal Turing machine, the definition is you have to be able to simulate the Turing machine itself. It kind of sounds like a circular definition, but like I said, a state machine is simply something that stores a state, records. You can change, either read, write to memory and everything like that. And so that's really like a simple explanation for it. But so why is Ethereum like Turing complete? How is it actually Turing complete? So Ethereum's ability to execute a stored program in a state machine called the EVM, the Ethereum virtual machine, while reading writing data to memory makes it Turing complete. And so right there is a visualization of that state machine. And so it's storing, like, all computers are storing this exact thing, but it's like, again, all of them have to make sure that they're all actually have the same state. And so you see program counter, gas, stack memory, Ethereum computer science, or ECE. This is probably very familiar to you. But the halting problem is a big issue, because if we can't know when a program will end, because the thing that makes Ethereum special, and why people are really interested in it, is the fact that you can write programs. You can actually build applications on top of Ethereum. Think of Ethereum as like, it's a little bit, not, I won't say a far comparison, but think of Ethereum as like the internet itself, right? It's like something you can build on top of. You can build all types of applications now on the internet, right, on the web. So think of Ethereum that way. But so the problem is, if we're having this one computer, this one network, right, and we're sharing all these resources, because everybody's sharing the resources that the network offers. If we don't know when a program will end, this can be really bad. And that's because when you're talking about a world computer, that means everyone is sharing the same resource. So let's say someone writes a code that has like an infinite loop. So in programming, you can write like a while loop. It's just saying like repeat this set of instructions over and over again. And if you have an infinite loop, meaning that there's a condition that you have to set while Armel is standing up in the middle of the class, do this over and over again. If I stand up here forever, that's going to go on for a very long time, and no one knows when it will end. And so that's a problem, because if it's using all the resources that everyone on this network is sharing, then no one else can run, execute, send transactions through it. You're practically clogging the network, right? And so how Ethereum solves this problem is with gas. And so gas isn't actually, so anyone that's used it, gas isn't like, at first I thought gas was like transaction fees. It's sort of like that, but it's a little bit more little bit more complicated. And so each instruction has a certain has an amount of gas that it is tied to, and so there's a limit that how much gas like a smart contract can use. And we're really talking about smart contracts here because that's what has code and that's what can have that infinite loop. And so whenever you reach this certain amount of gas, like gas in itself is a unit. It's like this instruction to send our mail some ETH is gonna cost you like 1,000 gas, right? And then you pay those gas by using Ethereum, by using Ether, which is the cryptocurrency. And so because the invention of gas and this idea of having a limitation on what actually how many instructions a smart contract can actually execute, it allows Ethereum to be Turing complete, but also limit the amount of resources that is being used. So to just quickly summarize that is we're this world computer, we're all sharing the same resources, the same memory space, the same amount of blocks, we're all using the same thing, right? In this preview image, we all have the same set of memory, same stack and everything, but if a program is executing some code that is going to be using that indefinitely, we don't know when that is bad. So we introduce gas as saying programs can have, yes, question?
Does every program have the same amount of gas? Like, how is that determined?
So it's based on it's like when you're looking at it's based on the amount of code in there. I don't want to say lines of code because it's based on so specific lines of code takes up more gas than another. Like if you were trying to send someone Ethereum, than if you're initializing a variable, that's going to take different amount of gas. But the easiest way to think about it is the amount of lines of code and how complex your smart contract is. But there's just a set amount, but not every contract is going to have is going to be worth the same amount of gas. It's just based how many instructions is in your smart contract.
But there's a limit in Ethereum. There's a set limit that each program can have.
Yes, there's a set limit that each program can have. So there's nothing that's going to be over, but they're definitely going to vary from very small gas to the max.
How about there's the base fee that the network gets, and then there's the tip.
There's a
tip that's depending on how much traffic there's on the network at a given moment.
Yeah, and we'll go super more in depth into that about gas and everything. But what Abe was saying is that so you have the base that you have to pay. So in order to get your transaction in the block into a block, you need to kind of pay this base fee of okay, the base fee refers to
It's like the minimum transaction fee that it costs, like it needs.
Yeah, so there's that, but that ties in with the base fee ties in with the amount of gas you have. So you're taking what that base fee is and multiplying by the amount of gas this certain instruction takes or this certain contract takes. But then there's also a tip, and you use that tip to make sure to incentivize the miners to put your smart contract, put your transaction into a block. Again, we'll talk more about this. I'm going over almost all of Ethereum in this time span, but we're going to go into every single thing I've talked about today in detail. We're close to the end. But now, so there's decentralized applications, and so once you've built out this network, right, all these network want applications to be built on top because they're networked. They're not, so they go by the network effect, and the network effect is kind of circular because the more users a network has, the more developers will actually want to write programs and build applications on that. And but the funny thing is, the more applications that a network has, the more users, the more likely users will come, the more users that you can attract. So it's this circular pattern. It's the more users you get, the more developers. The more developers, the more applications. The more applications, the more options that users have, and it's just circular thing. So it's just a circular thing. So decentralized applications are going to be really, really huge. Are really, really huge for adoptions of different cryptocurrencies and different networks. And so, but what it simply is, it's you can think of them. Well, right now they're mainly web applications. They're not phones. So they're a web app. They're built on top of the open, decentralized peer-to-peer networks like Ethereum, and they're composed of either smart contracts as the back end. They're handling the logic, and then most of them use JavaScript for the front end to just kind of build out the actual what it looks like, make it all pretty. Does anybody know these three protocols? And then name, or not? Some of them are protocols. These three dApps. Some of them are protocols. Some of them are.
The bottom one's MetaMask.
Yes, sir.
OpenSea.
Uniswap.
Uniswap, exactly. Dope. So, and yeah, but to the end, sorry it took so long. I was supposed to end this a while back, but why learn Ethereum? We're really early. The internet really started becoming popular about 20 years ago. Bitcoin was created 13 years ago. And a lot of us Most of us aren't even, actually most of us are around that age. So think about add another 20 years. What could it be, right? Second, the demand is booming. So the growth rate of like the blockchain industry, the numbers can skew. I've seen 60%, 80% compounded annual growth. And then also Glassdoor says there's been an increase of about 300. There's been a 300% increase for the amount of demand for just blockchain developers and everything like that. Last, you're joining a movement that's wanting to build a more transparent and open system. So I think for anyone that is kind of against if you're against big tech and everything like that, then this is a movement for you. And this is something where you can make the most impact by being a developer and learning how to code. And there's endless opportunities. Like that quote I mentioned before, software really is just an extension of human thought and what you can think of. If you can think of it, you can probably program it. It might not be easy, but you can probably do it. So there's endless amount of opportunities, and I really hope you guys come around next meeting. I will be a lot better at giving this presentation. But with all that being said, thank you guys so much. We do have a Solidity, so here's kind of the general format. We'll do it next time. So usually I would end at around 8 o'clock. Our activity took a little longer because of how scattered we were, but usually I would end around 8 o'clock. Then our VP Roshan, he would come up and then he'll give a 5-10 minute presentation about some Solidity syntax. We'll go over that just to give you guys an overview. But then the rest of the time would be left for y'all to work on Crypto Zombies. So if you want to get ahead, go on a website called Crypto Zombies. The way you can think about it, it's like Code Academy, but for learning Solidity. But they make it through like a game where you're like building this little zombie game. It's not as hard as it sounds when you say that. When you're like, I'm making a game, it's like you're just kind of learning Solidity. So if you want to get ahead, get on Crypto Zombies. But next meeting, I'll make sure to stick on time and we'll go over Solidity and give you guys like an introduction from the syntax level. But please, fellow, this one is different than the other ones. This is asking for feedback. We want feedback. Really appreciate y'all. And this is also how we're going to keep track. So again, we are a different org, so we have a different like mailing list and everything. So make sure you fill this out just so we can double check if you're on the mailing list, and you can stay updated, and we can add you to like our database, everything. But with all being said, thank you guys so much for coming out. It's been an absolute honor to see all of you.